Hello, welcome everyone to the AI podcast. Today, our guest is Dr. Jennifer Prendki. She is the founder and CEO of Alectio. During last few years, all the different types of positions at different companies. She has served as expert and advisor at International Institute for Analytics, VP of Machine Learning at Figure 8, Chief Data Scientist, Head of Research and Smart Engineering at Atlassian, Senior Data Science Manager and Principal Data Scientist at Walmart Labs, Principal Data Scientist at IST, and Senior Data Scientist, Tech Lead at Yumi. Dr. Jennifer Prendki, welcome to the podcast.
Hi, thank you for having me today.
One thing that I noticed is that you coined the term DataPrepOps. Can you tell us about what DataPrepOps means and how is it related to machine learning research?
Yeah, absolutely. So, I mean, the first thing I would say is DataPrepOps is like a sort of like a very expensive, extended term with like lots of different ways of explaining it. So it's a little bit like MLOps, right? I mean, so I think everybody has heard MLOps, but it's still a little bit unclear like how to define this, right? So maybe I'll start from that perspective, right? I mean, so basically, usually the way I tell the story of DataPrepOps is that on the one hand, over the past few years, you've seen MLOps becoming more mature as a space. And the reason why MLOps was invented was essentially to assist data scientists and machine learning researchers who have like all the knowledge to build a machine learning model to actually figure out how to deploy that machine learning model, because typically the people who know how to build a machine learning model don't necessarily have the knowledge for deployment and pushing a model to production, right? And over the years, it became this more complex space where all aspects of machine learning engineering that can be automated or semi-automated has been taken care of by the MLOps space, right? I mean, so MLOps is like all aspects of operational aspects of machine learning modeling and deployment, right? And so in the same timeline, you also have seen like the data ops space, which is different from DataPrepOps, like mature as well, right? I mean, so you have companies like Snowflake, Databricks, like even the big cloud providers that have been providing more and more solutions for basically making it simpler to store your data, organize your data, assure the privacy of your data and whatnot, right? And when you look at what machine learning scientists do every day, they are using both, but there is a huge gap in the middle, right? And so that gap in the middle is basically like everything that needs to happen from the moment where you have collected data, you've put that data somewhere safely for later usage, and then the time where that data hits your machine learning model for training, right? And so in that gap, you have like, or basically operations that need to happen, like data labeling, like data augmentation, like synthetic data generation, even cleaning the data, removing everything that can be harmful to the model or whatnot, right? All of these things normally happen in a Jupyter notebook. And technically, typically, data scientists complain a lot that this is taking a ridiculous amount of their time, right? So DataPrepOps is this nascent space in between that automizes and operationalizes the preparation of a data set. And I would go one step further. I would say that like basically it's like operations for data preparation in a semi-automated way and in a near real-time way, right? I mean, so basically like really like the paradigm shift that DataPrepOps is trying to bring is the notion that data sets should not be considered as a static object. They should be tuned, optimized, and improved throughout your training process, just the same way that a machine learning model, the model itself needs to be, right? And it's actually interesting because like at the time when I coined the term about 2 years ago, 2.5 years ago, right? The term like data-centric AI, the concept of data-centric AI also starting like becoming like more popular, right? I mean, so the very sweet, like narrow and simple way of explaining DataPrepOps is to say that basically like DataPrepOps is ML ops for data-centric AI, right? And oftentimes people associate data prep to data labeling, but there's so much more And when you're actually building a machine learning model, of course, you know that, right? I mean, you know that you need to get rid of some of the data, apply augmentations or whatnot, right? I mean, so I believe this is going to be a booming space, and this is a space where I hope like more younger talent, like researchers, are going to spend more time in the next few years.
That is really interesting, and I can completely relate to it in terms of spending a lot of time, like you mentioned, in a Jupyter notebook. And a few years back, I remember a term was really famous called data wrangling. And the data scientists will spend a huge amount of time in Jupyter Notebook, wrangling the data, cleaning the data, and preparing the data for training a machine learning model. And now it's sort of like off the shelf, thanks to DataPrepOps. Is that one way we can understand DataPrepOps?
Yeah, absolutely. So basically, like for me, like DataPrepOps, you know, like basically, like I really see a parallel, basically, like a few years ago, like basically like the early stage of my career, right? I mean, basically like there was practically no support for the deployment of a machine learning model, right? I mean, so basically like and you had entire companies like investing tons of money on data scientists, and then those people were brilliant, building beautiful models, but those would never actually bring money to organizations. Absolutely. Right? I mean, so another way that I will say, like you know, like a way in which DataPrepOps is important is also like we're facing a new bottleneck, right? I mean, because now I think in the past years, through ML ops progress, but also foundational models, right, it's become extremely easier. Of course, it's not easy, but basically, like compared to like where we were at like a few years ago, you really don't need that same level of technicity in order to deploy and train a machine learning model, right? And all of the expertise of a data scientist now needs to go to data preparation, and that's costing a lot of money as well, right? I mean, so basically, like I think it's super important that, you know, like it's not just important for practitioners, it's also important for you know, like executives and people running companies to actually realize, like, look, as long as you're gonna do all of this data preparation manually or relying on service companies that do everything manually on the back end, you're never gonna be able to speed up, right? And so I think it's really interesting that nowadays, like that space is sort of like speeding up and taking more importance across the community because of generative AI, right? And because, of course, you know, everybody knows that generative AI is extremely data greedy. So all of that data preparation needs to be done like in a smarter way, in a faster way, right? And yeah, I mean, basically, like there are so many aspects of it that haven't been touched yet that, you know, like I really feel like there's more effort needed in this space. But yeah, I mean, I think like people who have been spending enough time like building like scripts to clean their data, you know, like semi-automate their data labeling process or whatnot, will know what I'm talking about, and basically say like, I wish there was a way to automate that part of my process. So this is basically my vision.
100%. I totally relate to it, especially training while training a deep learning model for computer vision, because that's sort of most of my research revolves around at this point. And annotating, labeling the data is so difficult. And even after annotating the data, there is a lot of garbage in the data set. Removing that and fixing that takes a lot of manpower to sort of get a good quality data. And while we are talking about data quality, can you explain to us what is data quality? And I heard you mentioning in one of your posts structural data quality and functional data quality. So what are these different types of data qualities?
Yeah. No, so look, like I think I'm among the people who've been advocating like a quality for data sets for many, many years now, right? I mean, basically, like I think like originally there's this belief that as long as you have a high volume, like basically like your model is going to perform well, right? I'm really glad to see that there's like a increased like realization among practitioners that basically like sometimes you're better off with like higher quality data, even though the size of the data set is a little bit lower, right? So what I call basically like a structural data quality is basically what you think of when you think about data quality, right? I mean, you think about like completeness of the data, how you're going to deal with missing like features, missing records, corrupted data, like basically like so those are all of the checks that typically like the data ops side of thing is going to take care of, right? I mean, so basically like so it's not anything groundbreaking, but it's something that needs to be you know, basically infused in the way that we consider the data for our machine learning models, right? However, I've been like pushing really hard for also the realization that structural data quality or data quality, like as a single term, right, is not enough, right? So let me explain. You can have perfectly good data that has like everything you need, right? And so it's like no missing records, everything's trustworthy, everything is like organized, structured in the right way, right? That does not guarantee your model is going to perform well. Why? Because there is a notion of applicability, right? I mean, so basically like if your data is really high, good quality, and it's not basically like useful for the type of model you're building, then there is no point in having like really high quality data, or having high quality data isn't enough, right? I mean, so stupid example you could think of is like, let's say I'm building like a lane recognition model for autonomous driving, and 99% of my data doesn't contain lane markings on the floor because it's like dirt roads on the in the mountain, right? I mean, so is it high quality? Maybe it's very high quality. Maybe your pictures are high resolution. Maybe everything has been validated properly. Still, it's not going to be of much help for your model, right? So usually, like what I like is like bringing the shift of like data quality to data value. Basically like a functional data quality is basically my other term for data value, right? I mean, and so basically like right now when you look at the market, there is like enhanced realization that quality or structural quality is important, and of course it's must have, but it's not sufficient to guarantee that your data set contains the right information or sufficient information for your model to actually you know, like learn from it, because at the end of the day, the process of training is is about transferring information from the data into the model. So if there is no relevant information in your model, even if quality is high, it's not going to be.
One question I had regarding active learning, and we'll get into it in a bit, and off the camera, we were talking about how you have worked on active learning, and I have presented one of your papers in my grad seminars during my grad studies, because my research was also on active learning. And one thing I understood from a collection of literatures that I had to review for my thesis is that active learning, one of the aspects what active learning proposes is that to create a good data set, because we are using a limited data set because we have a limited budget, we need to include data that is representative of all the variants, and at the same time it has good variants of each kind. For example, if I'm creating a binary classification model, I need to include probably a balanced data set from both classes, and also have to include different variants of both the classes. So is there anything missing from this assumption, or is that how you perceive active learning as well?
Let's say it's complicated, right? I mean, so basically, like, so you're absolutely right that fundamentally the main goal is to create some sort of balance, right? And basically like force, or it's like it's a technique that dynamically perceives and identifies from the state of the model itself and from the current predictions of the model, basically what's most likely to be useful next, right? I mean, so basically like the vanilla active learning is actually very simple. Operationally speaking, it's a little bit harder, but practically like what you're doing is like you take a little bit of the data. At first, you don't know much, so it's sort of random, right? then you annotate this data, you train your model, and then you're gonna analyze what's going on, right? I mean, so the least confidence querying strategy, which is like what practically everybody who does active learning uses, is basically like a consistent, like taking the state of the model, applying that model on the rest of the data, identifying where the model has uncertainties, right? I mean, and so basically it's like you're letting the model tell you what it needs, right? Where I think the technique is really interesting is like you want some sort of balance, but you don't necessarily want a balanced data set in the way you think about it, where you have two classes, you want 50-50, right? Because in practice, what happens is models are just like us. They tend to struggle more for some things than others, right? I mean, so basically, let's say you're trying to predict across like or between 10 different animals, right? It's possible that one or two classes are going to be harder to learn because they're more blurry or whatnot. So the beauty of active learning is because you refer to the current state of the model. If the model struggles with one or two specific classes, the technique is built in order to enrich your data set with more of the same examples before you annotate them, right? Because you only annotate them after you realize this, right? I mean, so the assumption is if the model basically generates a prediction with a low confidence score, then the likelihood that it needs help or the model needs to see that record is higher. And then basically you're going to oversample for this, right? And so I think this is like absolutely beautiful. It's like a way to let the model tell you what it needs without making assumptions as a human and without enforcing specific ratios, right? I mean, so people always assume that I need to feed my model the same representation, but like over the years, after doing a lot of research, I've seen many cases where, for example, for facial recognition, models tend to want to see more dark-skinned people because those are harder for the model
100%.
to learn of the absence of like shapes or whatnot, right? I mean, so,
luminance and brightness and whatnot.
Exactly, right? I mean, so basically, like, so it's like, for me, it's like giving a voice to the model in terms of what it needs, right? I mean, which is literally what active learning is trying to achieve, right? Now, what is really hard is most of the assumption until now on active learning is that you can trust the confidence score. And this is something that's basically like putting at risk by deep learning. So basically, like, it's very well known that basically like the techniques or the querying strategies, so the sampling method you're going to use for classical machine learning models tend not to work for deep learning because very deep like machine learning models and deep learning models tend to fail at self-predicting their confidence score. So you cannot trust the confidence score, right? Because of this, basically, like you need to actually have a more advanced way to actually select useful data because you cannot anymore correlate the confidence score with the usefulness of the data for the model, right? And so this is basically one of the things we spend a lot of time on, like actually finding like a real ways to predict usefulness of the data and informational density of a record which you haven't seen yet in order to decide whether or not it is going in the model.
That is amazing. And I'm so happy that I have someone to talk to about active learning because of my selfish reason. And I'm so glad that you are using active learning in Alectio as well. And I think it's a nice segue into what does Alectio does and how did you incorporate active learning in it, and what is Alectio? If you could tell us about that a little bit.
Absolutely. So historically, here's what happened, right? I mean, so I was a little bit like you, where I saw the, like the benefit of active learning, like really early stage, for the same reason as anybody who uses active learning, which was the budget I had in my past organization to annotate the data wasn't enough to basically annotate the entire data set, right? I mean, so and so I quickly realized there is potential here, but I also realized there is danger in like biasing models and whatnot, right? Still I really felt like at some point we're going to reach that state where there's just so much data for anyone to annotate that we're gonna find smarter ways, right? I mean, we're gonna have to find smarter ways, right? Back in the days, I was working for organizations that did naturally have a lot of data, so I had to explore the solutions before the rest of the market, right? But eventually, like basically, like I think the pain points I met back in the days are starting to happen for everybody because of generative AI. Like, I think we're reaching like the point where people just realize it's not possible to annotate an entire data set anymore, right? So back in the days when I started Alectio, there were like two sort of theory for people realizing like we need to make data labeling like smarter and more tech oriented, right?
Yes.
You had the basically the thought leaders that believe that they needed to find like better automation to annotate a larger amount of data, right?
Yes.
So for example, Snorkel is like one of the paths you can take for this. You have like automatic data labeling, which is you know, like basically like applying a machine learning model on your training data set, which in my opinion has a lot of risk because this is how you can potentially induce biases, right? I mean, basically. And then there is the other thought, the other way of thinking about this, which is, do you really need to annotate the entire data set? And so I was like an early like believer that you don't have to think about data volume, you have to think about information density. So you can have extremely large data set that actually contain very little information. If you know where the information is, then basically like you can get away with a relatively low budget, right? And so this is how Alectio was started, right? I mean, so basically I wanted to provide solutions for people who knew nothing about active learning and specifically did not know how to tune active learning, because active learning is very use case specific, right? To basically like just like plug their model, plug their data and get running with it, right? And then over time, I quickly realized like what I'm trying to do here is to dynamically update the data set, right? And this is really something that has never been done before, right? And because like ML Ops helps you tune your model in real time, Data Ops helps you manage your data set in a static manner, a slow-paced manner, right? And so basically like this is a new paradigm where you're allowed and you have to touch your data set during the training process, right? And then I started realizing that basically like, look, if you're going to select data in real time, you're going to have to label data in real time, right? Is auto-labeling the only way? It's one way, but you can also like figure out ways where you make like manual data labeling, like synchronous, right? I mean, I'm basically like making sure that, you know, like there's synchronicity, you can send data in real time, get your results in near real time and whatnot, right? I mean, so we started building all of those pieces where really like what the Alectio platform has become today is like this system where whatever changes need to happen in real time for someone to optimize their data set during the training process, whether that be through selection, through updating of the labels, through applying like a specific augmentation on a specific record or whatnot, plus all of the infrastructure that goes with it, the management of the data, the versioning that needs to go with it, the analytics that goes with it and whatnot. So basically that's what the Alectio platform is today, right? I mean, so it's like the ambition is really like to provide solutions so that people can get running today with the real ability to tune the data as they've trained their machine learning models.
Yeah, and you brought up a lot of terms that I haven't used for a while. For example, you used the term information density, and another similar word that I found in the literature is informativeness. And I remember reading a paper that talks about Fisher information equation to measure how much information there is in the data set. And I'm guessing that you have some way of measuring informativeness or information density in your data set as well.
Yeah, absolutely. So you can look at the problem in several ways, right? I mean, so basically like in fact what's interesting is basically like you have like the regression approach, which is measuring basically like a usability or informativeness score, right? What's interesting is like I'm also trying to, so basically like with a Fisher approach, you're not necessarily thinking about the level of information applied to a specific model, right? I mean, so I really like the idea that with the concept of active learning, you're really looking at, you know, like relative information, like a level of information, right? I mean, which can be this specific record is super useful for model A and it's not useful for model B, right? I mean, so basically like this is also a shift in paradigm that even if you're working in with information theory or information intensity, sorry, like you don't necessarily think about, you know, like the dependency on the model that's going to consume that information, right? The other thing that I think is interesting is like instead of like where active learning is different from that kind of like a information theory based approach is basically that it's really a ranking system, right? I mean, really what you're trying to do is not so much like just like putting a score, but really prioritizing the data that's the most useful, right?
Correct.
And so this leads me actually to another topic, right? Which is normally active learning has been built with that labeling problem thing, right? I mean, so originally people invented and started using active learning because they wanted to reduce dependency on data labeling, right?
Yeah.
I think there is a full like ocean of new applications which we're also trying to bring forth, right? Which is like, if you really believe in your active learning process as a way to prioritize the most valuable information for a model, then that can translate into explainability, right? I mean, basically you can really try to understand which part of the data actually helps the model the most. So it's like an entire topic where you can try to see like what is so special about the data that was the most useful for a specific model. Then if you find out that statistically speaking, the most useful and least useful data have in common or in difference that one has a high density of trucks and the other one has a low density in trucks, then you know trucks are helpful for this specific model to learn faster, right? And so basically like there is a ton of work that needs to be done in terms of like correlating like the shape of a learning curve class by class and basically looking at what's going on in that specific like a data set and that specific selection process at a point in time, right? That brings you like a ton of information about how you should collect your data, how you should fix your model, where your model is weak, right? Another thing that I love about active learning is because it's an incremental training process. You really can follow all of your model's metrics in real time, right? I mean, so basically, like think now you're not just looking at a loss function like across like one specific like process. You're basically looking at, geez, like when I added this specific part of the data, this is like what happened to my model. You can see this is the exact point in time when my model started overfitting. This is the exact point in time when my model stopped learning a specific class, because you can keep track of your confusion metrics dynamically, right? And so basically like this is literally the only process or the only technique that you have to do these kind of things, right?
Wow, that is really interesting how you connected active learning with explainability of AI. And it's so funny because my supervisor from my grad studies is actually looking into explainability of AI, but I'm not sure if he's looking at active learning. I was probably the last student who looked into active learning because we didn't have a lot of literature at that time. So that is interesting. You are from educational background, you are a physicist. So my question to you is, how did you how did you got sucked into this world of machine learning and AI, and how was the transition for you? And also, was there any similarity in the two fields that you found?
No, absolutely. So look, so I would say like it all started by accident, because basically like, so when I graduated with my PhD in particle physics was basically in 2009, right? I mean, so that was the year when the Great Recession started. And
I was in high school.
Obviously there was like less and less like basically like you know, like money for fundamental research or whatnot. And so like as being a particle physicist was what I wanted like ever since I was a child. So I was like, oh, I know, you know, like basically like that was really like a kind of like a big change in my life or whatnot. But it was a very typical move back in the days for particle physicists to transition first and foremost in quantitative finance, right? And because like differential equations or whatnot, right? And after transitioning, so basically like I did what I had to do, right? Being somebody with an applied mathematical background, like it wasn't such a huge shift after all, right? I mean, because like modeling and resolving complex equation, like programming or finding ways to like you know, like solve these equations faster is like what people in finance do as well, right? And I basically like at some point I got lucky to be, you know, like the firm I was working for, like basically like the hedge fund I was working for, wanted to start doing research in NLP, like basically based extraction of what's happening in the news. So basically like early stage, like topic modeling, like basically models and whatnot, right?
What year was it?
To like 2011, right? I mean, so basically
Wow,
like so back
long time ago.
in the days, I was like, oh, this is interesting. You can model language, and yes, it's very similar to a lot of the things that you would do as a particle physicist, right? Because like what particle physicists really do is like take a huge amount of data and finding patterns in it, right? And I actually like what was interesting is like back in the days, like particle physicists had a lot more data than you can imagine, and like really similar in terms of like size that what you can see like in machine learning today in the industry, right? And at the same time, we did not have big computers, like so we had a tiny computer farm with limited resources, right? I mean, so this is where my approach for like a frugal machine learning or like limiting the amount of data that you need to use came to me, right? And so when I joined the industry, it's like, why is nobody thinking about like how to be more pragmatic about the data, the quantity of data that gets fed into the model, right? I mean, so anyways, fast forward, this is how I eventually jumped in NLP and machine learning. So the rest is history. Basically, like I became what people call today a data scientist. I started like working for larger organizations, and I started leading teams. And so at some point I realized maybe there was something with my idea of like reducing the amount of data, because this is just not going to scale. I did not trust basically like hardware to be the solution for the foreseeable future.
Now it makes more sense to me why most of the data scientists, I'm going to call you a data scientist because after all you work with data, who have been working in the field for, let's say, 20 years or 10-20 years, are mostly physicists and mathematicians, because back in the day we didn't have programs for teaching machine learning. Now
exactly, I was gonna say, like when I started my career, there was no degree for like there were a few degrees probably for AI, but that was very niche, right? I mean, basically I think we're going for an AI winter back in the days, right? I mean, so now it's like
now you have programs, in fact, in our university as well, University of British Columbia, we have we have courses on optimization for machine learning. So that is a separate course, a 4-month course talks only about how different optimization algorithms work. So that it just shows how far we have come in last 10-20 years.
I will add to that. That was fast, right? I mean, after like, because like when I look at like even 5 years back, like nobody was using the term MLOps, right? I mean, just look at it today, where you have the like landscape maps with all companies like dealing with MLOps. Like these are so huge, right? And basically like this is where I anticipate like a huge shift for data-centric AI and DataPrepOps in the next few years as well. Right?
100%. Shifting gears a little bit here, because you have worked with NLP before during your research. And my question is, what is your opinion on the current trend of AI research, especially regarding LLMs with billions of parameters? And I saw your post on LinkedIn, how you mentioned that the current LLM models have billions of parameters, whereas the in physics, you use less than 20 parameters to explain the equation that explains most of the theory. And what's your opinion on how these models that we build?
No. So basically, look, like I'm a scientist at heart, right? I mean, basically that's my background. Like basically, like I think there is really something to be said about like being pragmatic, and like let's talk about the concept of modeling, right? I mean, so basically like fundamentally the idea of modeling, like I don't know if you know that saying, like all models are wrong but some are useful, right? I mean, so fundamentally the concept of modeling is finding like an alternative way to explain something that is simplified, right? And I think there is nothing in like there is no simplification in our approach to building models of language nowadays, right? I mean, so basically, like, so my criticism is the following. So it's not necessarily a criticism, because language model has nuances or whatnot, where, you know, like basically you could argue that basically like a physics is trying to represent like the fundamental matter of the universe, and then you try to explain on top of this. So
Yeah.
the way I look at like the standard model is like it's a way to decode the universe, right? I mean, so basically it is simplified because you take that model, you apply it on what you can observe around you, right? I mean,
Yeah.
what deep learning models are trying to do is really, like, in my opinion, it's more like getting a full-fledged answer and encoding information, right? I mean, so I think that was the topic of my post, right? I mean, which is like,
Yeah.
what's the difference between modeling and encoding information?
Yeah.
It is possible that in the case of language, like there is no easy way to model, right? I mean, so basically, like, so it's probably the case. But what my criticism here is like, so this is actually interesting. So the human brain is typically known to have 100 billion neurons, right?
Yeah.
And out of the human brain, like there's an estimate of like about 6% of that being used for language, right? So basically, like if that's true, that means that only 6 billion neurons are being used for this, right? When you look at the evolution between GPT-3 and GPT-4, whenever basically like the model doesn't work well enough, or they're trying to improve the model, the solution is to dump more complexity, more layers, and more neurons or whatnot, right? I mean, so of course, I'm not claiming you can reduce human language to a model with 20 parameters, right? But what I'm claiming is like complexifying things is not always the way to go, right? And so basically that goes back into larger models require more training data, require more resources, require more compute. And I don't think this is going in the right direction, right? I mean, so basically, like, I really truly believe, like, I love posting about basically the analogies with, you know, like neurology or whatnot. But for example, I'm a big believer that there's something we haven't modeled in the way that the brain basically filters out information. Like basically, like there's been research that showed that when, you know, basically like somebody talks to us and there's like a peripheral information, we shut down our perception levels to some of the things that we know will not be useful for analyzing the information, right? I mean, so for example, when I'm talking to you, I may be not perceiving what's going on around me, right? I mean, because I'm focusing on our conversation, right? So that kind of paradigm, in my opinion, is something that's completely missing from the way that we're developing models, right? And so basically, like, I think, you know, like, maybe I'm a romantic, but basically as a scientist, I really feel like there's more to explore. There are new architectures we need to look into that we really need to bring on to the conversation, instead of just like making those models constantly bigger.
Interesting. And regarding ChatGPT and GPT-4 model, because it's been trained with billions of parameters, how do you perceive a model like that? For instance, there was this article from Washington Post that compared ChatGPT at that time, because it was a few months old. And they compared it with a bad JPEG of human knowledge. So my question is that how you see it? Do you think it's intelligent? Recently, Lex Fridman interviewed Sam Altman, and they used a lot of times they use the word intelligent, innovative, this kind of words they used to describe their model. Do you actually believe that? Do you?
No, look, I'm Team Jan LeCun all the way. I don't think this is innovative. I think it's very brute force, right? I mean, because ultimately, at the end of the day, all of the GPT models are essentially like supervised or self-supervised machine learning models. There's nothing new about it, right? And as I said earlier, it's encoding of information. Why is it a bad representation of human knowledge? Because it's trained on the internet. Or not all of the internet is useful. Not all of the internet is true, right? I mean, so basically, like right now, with no filter to like basically like input that information, I actually think that GPT models like basically like translate or transfer knowledge from data into the model pretty well. And why wouldn't it, right? I mean, when it's so large, right? I mean, so basically, like I think like you know, like you're making something that's practically as large as the internet itself, right? In terms of complexity, right? I mean, so I believe it's a useful model that can basically like recreate and extrapolate from what it has learned. But
Yeah.
like it becomes a data prep problem when you do not filter or intelligently like select the data that goes into those machine learning models, right? I mean, so
Yeah.
if 20% of the information on the internet is nonsense, is false, is fake information or whatnot, this is going to land as is in ChatGPT, right? I mean, so basically there's no surprise that it hallucinates, right? I mean, basically, like for me,
Yeah.
like hallucinations is just like answering to stuff it hasn't seen or it hasn't
Yeah.
clearly seen enough, right? And
Yeah.
sometimes you're gonna have wrong answers, not because the
Yeah.
model is stupid, it's just because you're just like transposing or bringing back what you've learned, which was wrong, right? I mean, so it's
Yeah.
no different that if you teach something wrong to a child, they're gonna make the same mistake over and over again, right? I mean, but
Yeah.
fundamentally, I like, to me there is no intelligence in there, right? I mean, it's like for me, like true intelligence is really like the ability of creating new ideas,
Yes.
the ability of like having logic or whatnot. Like this is a big like digitalized encyclopedia that can reframe and restructure sentences, right? I mean, so basically, like for me, it's
That makes
nothing
sense
more,
to
right?
us. Yeah. That sort of restructures sentences in a way that makes sense to us as humans.
Yeah, absolutely.
Hmm. That is interesting. And recently there has been, because we are moving so fast in terms of AI research, there has been a demand for pause in AI research by Elon Musk, Steve Wozniak, and a lot of people. And do you think that it's a good idea to pause AI research, or do you think we should move slower? Or
I think, you know, like what I would say is like useless or not, like, so basically I will say, like, in my opinion, it's mostly that it wouldn't work. So I really relate to the fundamental feeling here, which for most signers of the letter, in my opinion, comes from look, we're not ready for that as a society, right? I mean, so basically, like, I personally, I'm sort of upset that we've been like basically experts and especially ethicists have brought in, like, you'll see the day where we reach like that kind of capabilities, we're not gonna be ready. There's not gonna be copyright laws ready for this. There's not gonna be a framework to provide to protect, so like a, you know, like a privacy, to make sure children don't access content they're not supposed to, because think
yes,
about it, like any child can go in there and basically like search for inappropriate content or whatnot.
yes,
There is no
yeah,
safeguard. So for
yeah,
me, this should have been done years ago, right? I mean, so I see the demand for pause as almost like a cry for help, that basically like, wait a moment, governments, organization, and we the people are not ready for this. At the
hmm,
same time, people are excited, so basically like there's like this craze that's going on, right? And
yeah,
basically like, so for me, like, we should not have ever needed for a letter like this, because we should have been prepared for the
hmm,
moment where this was going to happen, right? At the same time, like, there's other like people who have been criticizing the letter as being like, you know, like this is a desperate attempt from some people to try to catch up with the rest of the organizations, right? And so, for example, like a lot of people have been criticizing Elon Musk for this, because
yeah,
it almost sounds like he's trying to like buy himself time until he can catch up
100%.
with the
Yeah,
rest, right? I mean, so basically, like, I believe that like he's probably an exception. I don't believe, like, you know, like people like Steve Wozniak actually believe that. I think there is genuine concern for
yeah,
getting ready, right? I mean, the problem I
yeah,
see right now is like, you cannot enforce such a pause. You'll always have somebody like training like a
yeah,
GPT model in their backyards, right? And basically, like, I
yeah,
think it's late for that, right? I mean, so basically, like I understand the intent. I relate to the intent. I also believe that we have a lot of catching up to do from a regulation and an
yeah.
ethical point of view. But I think like we need to manage things the best we can given the situation right now.
Hmm. I mean, that is such an important point that you mentioned, that anybody can run machine learning model in their backyard, especially with really good parallelism mechanism that we have. For instance, Colossal AI sort of came up with this parallelizing mechanism where you can run LLMs on your own personalized devices with a lot less GPU than they sort of usually sort of you see in the technical reports or papers by GPTs. For instance, Bloomberg GPT, they used a lot of compute power, and now you can run not very similar, but slightly scaled back down versions of these LLMs using your own devices. So yeah, that totally makes sense, and I don't think it's possible to scale back at this point by pausing AI research.
If anything, I will add
yeah,
that if anything, it brought attention to people about the importance of
yes,
regulation, right? I mean, so I
yeah,
think like regardless of the outcome, I know it brought like a huge outcry, among experts and non-experts alike, right? People are talking about the right things now, right? I mean, I think after
100%.
that, like basically, there's been like conversations about like privacy issues, do not put your
Yes.
own data in ChatGPT and whatnot, right?
Yeah.
I mean, so it's at least it's bringing the conversation in the right direction. So this is very
Yeah.
important.
Yeah, and to ChatGPT's point, OpenAI's point, they mention in the disclaimer that we will use your data to retrain our model. And people are so crazed by ChatGPT that they sort of chose to ignore the caution and put in their data in it. And now employees from Samsung did the same thing. And now their proprietary data is living inside OpenAI's database. So that is just hilarious to me. Okay, and now that we are moving towards the end of our podcast, I have two more questions for you. And it's important that we sort of moved into discussions about how we are moving regarding AI research. And one question that I ask all my guests is that there is a raising concerns that AI is replacing human workforce, and that is a problem. How do you see it evolving, and how can we create a more sustainable environment where humans can use AI as a tool and not as a replacement for humans?
Yeah. No, look, like, so I think there are two schools of thinking over here, right? I mean, so you have the people who tend to panic, like basically I'm losing my job,
Yes.
and basically AI is replacing me or whatnot, right?
Mm,
Like the other opposite people is just, like AI is not going to replace people, but people using AI are going to replace people who are
mm.
not using
Yep.
AI. So
Yep.
I'm sort of in the middle, right? I mean, so basically, like, look, this is no different from like any like technology revolution, right? I mean, so
Yes.
basically, like at some point, automation basically like made some jobs irrelevant. I
Yep.
don't think AI is replacing people, but AI is going to automate some jobs, right?
Yep.
Now, I think these are the jobs, like the jobs that are easy enough, or like basically like to be replaced or whatnot, right? I mean, basically like it makes sense to replace them so that we humans can focus on like something more
Yeah.
interesting, right? I mean, so basically like if
Absolutely.
like jobs that are dangerous, that are like can cause like diseases or like accidents or whatnot, can be replaced by machines or by AI, I'm all for it, right? I mean, basically like if doctors can use like a medical chat GPT to have better diagnosis or
Yeah.
whatnot, like go for it. I don't see any reason for stopping this, right? But so I think people are gonna have to like get used to it and not basically like push back, right? I mean, so basically like I think there needs to be a movement of like like adoption, that basically like you should not see this as like I'm being replaced as a human. It's some of the skills that used to be like managed by a human can now be managed by an AI. I can retrain, learn new things, and push my own skills and my own abilities to the next level, right? One
Yeah.
thing I'm a big believer in is like, look, again, because generative AI is actually like, I actually don't like the term generative, right? Because generative gives the idea of like innovation, creating something
Hmm.
new. it is not creating something new, it's rephrasing, right? I mean, it's just like
Yeah.
basically like I challenge basically like somebody to use ChatGPT to have the model train, like think back in the days when electricity did not exist, right?
Yeah.
If electricity did not exist, you would ask ChatGPT what are ways to light up like the streets of a city at night. You
Yeah.
would have seen nothing else that candles, right? I mean, basically
Yeah.
because it's learning from the data it has been fed and extrapolating on that information, right? Innovation and creativity comes from disruption, right?
Yeah.
So this is typically new ideas are not an extrapolation of something that can be seen in past info, like in past data, right?
Yeah.
So this is true of artists or the output of artists. It's true of inventors and whatnot, right? I mean, so if anything, if AI and large language models give us the opportunity to focus on inventing new stuff, I think it's all, you know, like it's a huge benefit for humankind, right? As
Yeah.
long as people don't perceive it as, you know, like my life has no sense anymore, right? And then
Hmm.
basically my life has no sense anymore.
Awesome. Dr. Prendki, that's all the questions I have. And we are at the end of our podcast. And thank you so much for being my guest. You are, in fact, the first female guest on my podcast. And the good thing is I have next few interviews with other female guests as well, which I always wanted to bring in more female guests to my podcast because, of course, we want to highlight more women in data science and AI and machine learning research, of course. So please, if you want to end this with some parting thoughts, that would be perfect.
Well, I mean, so yeah, I mean, I think like the last point we just made, right? I mean, is really, really, really important for me because
Yeah.
like I think we are at an important like turn in the story of humankind, right? I mean, so basically, like I think we all need to like step into the future like responsively, like basically like with no panic, but also with
Mm.
no, you know, like without being like you know, like despondent about what's showing you know, like basically like
Yeah.
there's no reason to panic. We can use new technology and this new technology in particular to our benefit, but
Yes.
it's important that everybody remains pragmatic and that all aspects of society are, you know, like contributing to the conversation. I think it's very important that, you know, like we experts in AI like evangelize what's going on, explain what's going on to governments, to non-technical people, so that everybody can do the best use and contribute to making all of that new technology beneficial for everyone.
Perfect. Dr. Prendki, thank you so much for coming to the podcast. I'll end the podcast now. To our viewers and listeners, I will see you next time. Thank you so much.
Thank you. Bye.